Okay, so we got the mass calculation in here. Okay, so let's see. So first you need to know what is given. 0.175 grams of gold, that is here. AU is the gold. Then what do they want? They want to calculate the mass of chlorine. Chlorine is just here. Okay, so I'll draw the table. Ratio, mass. So what is given to me is gold, which is AU, and what is the ratio number of AU is just 2. Okay, and what do they want you to find out? Chlorine, CO2, and what is the ratio number is just whatever in front of it is 3. Cool. Okay, now I need the relative formula mass RFM of what? AU is what they just told you, 197. A and small u, AU. The other one is CL. Well, actually you want CO2, remember, you go into what? CO2, yeah, which is CO2, sorry, 2 times 35.5, which makes it 71. So the gold AU is, if you look at it, they told you 0.175 grams, so it's 0.175 divided by gold on the relative formula mass is 197, which will give you a fraction. Just keep it on a fraction, so it's more accurate that way. 0.175 divided by 197, that give you 7 over 7,000, 7,880. Then 2 to go to 3, what do? You just multiply it by 1.5, yeah, same thing, times it by 1.5. Just put it on the calculator, say sign times it by 1.5, which gives you 21 over 1,500 and, sorry, 15,760. Then just multiply that straight away by the relative formula mass of CO2, which is 71. We worked it. Just put on your calculator, just put times 71 without even changing anything. And I want the decimal, I want the answer in milligrams, that's what they said. Okay, so 0.0946 946 grams, but they want it in milligrams, so you just times this by 1,000 to convert it into milligrams. Okay, how many milligrams would this be? So that will give you 94.6 milligrams is the answer. Okay, because since they want it in milligrams, there you go, that's the answer. Okay, maybe. So again, what do they want? What is given? 25 grams of ammonia is given. Okay, ammonia is NH3, this thing, NH3, ammonia. They want you to calculate the mass of hydrogen, which is this one. So ratio, mass. So what is given to me? Ammonia. Ammonia is NH3 here. And what is the ratio number is 2. And what do they want me to find? Hydrogen, which is H2. And what is the ratio number is 3. I need the relative formula mass. I'll just work it on this side. Relative formula mass of what? First NH3. Nitrogen is 14 plus 3 times hydrogen is 1. They just told you. That makes it 17. Then the other guy is H2. That's just 2 times 1. That's just 2. So the mass of ammonia they told you is 25 grams. So 25 divided by the relative formula mass of NH3 is 17. Oh, that's the fraction then. It doesn't simplify. Okay. Then to go from 2 to 3, times it by 1.5. Okay. So 25 divided by 17, of course that doesn't simplify, times it by 1.5. Which will give you 75 over 34. Then you times the answer by your relative formula mass of hydrogen, which is 2. And now you give it on a decimal. What does it say? 4.41 grams then. Okay. Times it by 2, which gives you 4.41 grams of hydrogen that is needed. Okay. Next one. Now calculate the mass of maximum copper that is produced in grams. You should determine the limiting reactant. Okay, first of all, let's determine the limiting reactant. Now you got two things. So I'm going to say I do not know this guy, and I will say, oh, I want to find this. Okay, so I got 108 grams of aluminium, which is here, aluminium, and then what you're trying to find, or kind of, you say, oh, I do not know the copper chloride, and I'll try to find the copper chloride. What is copper chloride? CuCl2, that's copper chloride. All right. Okay, let's work it. Now, so aluminium is given AO, the ratio number is 2, copper chloride CuCO2, that's 3. Now, the relative formula mass, I do not need to work it out since they already gave it to me. And I already have the atomic mass also, those things are given to me, so I'm not really working it out, okay? So the mass of aluminium is 108 grams, okay, 108 divided by aluminium is 27, divided by 27, that gives you 4, okay? 2 to go to 3, you times it by 1.5, so what is that then? 4, what do? You times it by 1.5, that makes it 6. 6 times it by the relative formula mass of CuCO2, copper chloride. CuCO2 is 134.5, which gives you 807 grams. Now, but they said is 1.21 kilogram, which is what? 1,210 grams, right? So, which is excess? Now, if you think about it, look at it. You got too much. This is too much compared to 806, 807. So, this is your excess. And this is your limiting. So, what is your limiting reactant? Your limiting reactant is what? Your limiting reactant, you should write which aluminium. That's the limiting reactant. You should write it for them. And what would you like to calculate now? You will have to use the limiting reactant to calculate the mass of copper produced. So copper produced, copper is here. Where is copper? Here. So I'm just going to put it here. Ratio, mass. So you know aluminium and copper. Aluminium was relative, the ratio is 2, copper is 3. Aluminium was 108, that's what you use, divided by aluminium relative formula mass is 27, which makes it 4 to go here. So oh god, it's times same thing, isn't it? Times it by 1.5, times it by 1.5 is 6, times it by copper is what? Copper number is 63.5. Which gives you 381 grams. Is the answer. Okay, and that's what you write. And also they also want the aluminium, so you should determine that limiting reactant which we have. Okay, moving on. What is given? 11 grams of copper chloride. What is copper chloride? Copper chloride. And what would they found you to find? Calculate the mass of copper carbonate. So what is copper carbonate is here. Ratio, mass. What is given? Copper chloride, which is CuCO2. What is the ratio number? What is the number in front of it? There is no number, so automatically is 1. Yeah, what do they want you to find? Copper carbonate, which is CuCO3. What is the ratio number? What is in front of it? There is no number, so automatically 1. So I need the relative formula mass of them. First CuCO2, that's Cu is 63.5 plus 2 chlorine 35.5, isn't it? Which will give you 134.5, and the other one is CuCO3. Copper is 63.5 plus carbon is just 1 carbon, 12 plus 3 oxygen, 3 times 16. That will give you 123.5. Okay, first copper chloride. How much copper chloride do you have? You got 11 grams. So 11 divided by CuCO2 was what? 134.5. 11 divided by 134.5, which will give you 22 over 269. It's just 1 to 1. It's just the same thing anyways. 1 to 1 is the same thing. What is it? 22 over 269 then. Times by relative formula mass of CuCO3, which is 123.5. which will give you 10.1 grams. 10.1 grams of that, and that's what you want. Okay, next one. The percentage yield. Okay, the formula for percentage yield is not given. You need to know the yield is, okay, actual mass produced, which is the smallest number, divided by your theoretical mass multiplied by 100. Okay, so they want the actual mass produced, which is whatever, and they said the percentage yield is 79.1, which is, as a decimal, is 0.791 because you divide by 100, right? Now you could see, think about this. Your theoretical mass is this one of what? Of copper chloride, yeah, not this number. A lot of people think it's a continuation question here. They will think is that no, this is copper carbonate. No, copper chloride, the theoretical mass is 11 grams. Is that making sense? Yeah. Okay. Don't think because we worked out this one, this is what we use here. No. They want copper chloride. Always read it. Okay. Copper chloride, the theoretical mass of copper chloride is 11 grams here, and they want actual mass. Now, so because it's 11 grams, now you could do two things to it. You could either multiply it or divide it. Remember, your actual mass is always smaller. Okay, always smaller. So which would make more sense, to multiply it by 0.791 or to divide it by 0.791? Remember, because it's 0. You might think if you divide it, the number gets smaller. No, the number gets bigger when you divide it by a no point, isn't it? So you multiply times it by 0.791, it will get smaller now. Okay. Which is 8.701 grams. Which will give you 8.701 grams. Okay. Now, so always think, if they want you to work out the percentage yield, that's the formula to go through, just that. If they want you to work out the actual mass or the theoretical mass, always they will give you the percentage yield. You either go times or you go divide. Remember, actual mass is the smaller number, remember. Okay, so whichever gives you the smaller number for the actual mass. If it was theoretical, then you need the bigger number, make sure. So you either times or divide. You will always see. Okay, so 2 marks, simple. Right, the next one. It's a volume question, but then technically it's a mass also. So let's see. What is given now? They gave you 100 kilogram of titanium dioxide. What is titanium dioxide here? That is titanium dioxide. What would they want you to work out? Calculate the volume of chlorine gas. Okay. So similarly, so ratio mass. So what is given to us is titanium dioxide, which is TiO2. So the ratio number in front of it, there's no number, so automatically 1. They want chlorine gas. What is chlorine gas? This is chlorine gas, yeah, Cl2. CO2. What the ratio number is? What is in front of it is 2. There you go. The relative formula mass of, well, normally we do TiO2, but in this case we don't need the CO2. I'll show you. The TiO2 is what? 48 plus 2 oxygen. 2 times 16, that makes it 32. That makes it 80 then. Okay. So now a lot of people put it as 100 kilogram. Don't put it as kilogram. You're allowed to put kilogram if on the other side you get kilogram. Then you're okay. On this one, they want the volume, so you're not really going to do it. So you must make it into grams. What is this? 100 kilograms into grams is 100,000. Divided by the relative formula mass of that is 80. So what is 100,000 divided by 80? Which is 1,250. The unit is technically moles. So 1 to go to 2, what do you do? Times it by 2. So you times it by 2. That will give you 2,500. Now, instead of multiplying by the relative formula mass here, which remember I said we don't need it because we want the volume, they just clearly said 1 mole is 24 decimeter cube. Times it by 24. Okay? Which makes it 60,000 decimeter cube. Because what do they want the answer in? Look, decimeter cube. So it's 60,000 decimeter cube. If you want to go centimeter cube, remember, you have to times it by 1,000. Okay, times the decimeter cube by 1,000, then you will get a centimeter cube. Okay. Next one. Show that aluminium is the limiting reactant. Okay, so whenever I get a question, I always say, oh, the second one, I don't know what it is. Okay, so I'm going to say this is given to me, which is 1 kg of aluminium. Where is aluminium? There you go. And what do I would like to find out? Iron oxide. I don't know how much is iron oxide. This is iron oxide, yeah. So what is given to me? Aluminium is given. Iron oxide is what I want. Fe2O3. Ratio numbers are 2 and 1. The mass of aluminium, am I okay to put kg? Why not? Because on the other side, I can work out the answer in kg. In here, I want kg, but I'm not working on kg. I'm working on volume, which is technically like a centimeter cube, decimeter cube. Okay, so you can't use kg. You have to use grams. In here, if I use kg, I get kg. If I use grams, I get grams. I'm just looking for kgs, so it's fine. Kg. Okay. Kilogram. How many? Aluminium is 1 divided by relative formula mass. I forgot. What is aluminium? Is 27. They told you. Fe2O3. What is Fe2O3? 2 times Fe 56 plus 3 times oxygen, which is 16. That gives you 160. So aluminium is 1 over what number? 27. So what do you can't simplify that anyways. 2 to go to 1, what do? You just divide it by 2. Divide this guy by 2 then. You're only allowed to, remember in here, you're allowed to times or divide here always, yeah. So 1 over 27 divided by 2, which gives you 1 over 54. Then what do? Times it by the relative formula mass of this, which is 160. Times it by 160, which gives you an answer of 2.96. 2.96 kilograms, remember. Look at this. This is 2.96 kilogram. And what do you have? You got 3. So that means you have 3 kg of Fe2O3. That means that guy is in excess. So aluminium, if one is excess, the other one is limiting. Okay. Next one. So we got ratio. Nope. Ratio and mass. So what do we have? We have a 2000 kg of aluminium oxide. This is aluminium oxide. They would like you to calculate the mass of oxygen. So calculate the mass of oxygen. Oxygen is that one. So aluminium Al2O3, aluminium oxide, they would like you to find oxygen. Ratio numbers are what? 2 and oxygen number is 3. Now, am I okay to put kg? Yes, because look, my other answer, I want it in kg. So I'm perfectly fine to put kg there, sure. Let me work out the relative formula mass, RFM. Al2O3, that's 2 times 27 plus 3 times 16, which gives you 102. And the other one is O2, which is 2 times 16, that's just 32. Right, aluminium mass is 2000. I can put 2000, it's not a problem because I get it in kilogram on the other side. Divided by aluminium oxide Al2O3 was 102. I can simplify 2000 divided 102. That gives you 1000 over 51. 2 to go to 3, you just times it by 1.5. So what do you do here? Same thing, isn't it? Times it by what number? 1.5. Just put times 1.5 on the calculator straight away. 500 over 17. Then you multiply by relative formula mass of that, 32. Just put times 32. 941.2. 941.2 kilograms is the answer. Because you put kg, you'll always get kg out. Good. Show that titanium chloride is a limiting reactant. So I always cross off the second one for the easiness of it. Okay. just go ratio mass, and what is given, so I'm just going to assume 40 kg of titanium chloride is given. This is titanium chloride, and what will they want you to count? Sodium, which is here, TiCl4, ratio number, there's no number in front of it, so automatically it's 1. Sodium is just 4, I need the relative. Formula mass, TiCl4, Ti is 48 plus 4 times 35.5, which gives you 190. And the other one, sodium, is easy, just 23 anyways, right? So titanium chloride was 40 kg, right? 40 divided by 190, that simplified gives you what, 4 over 19. 1 to go to 4, you just times it by 4 to go there. You do the same thing, times it by 4. 16 over 19, just times it by the relative formula mass of sodium, which is 23. As a decimal is 19.37 kg. But if you look at it, how much do you have? You have 20 kg of sodium, so it's a excess, because remember you need that much only, but you have to equate 20 kg. So aluminium, not aluminium, titanium chloride, TiCl4, is limiting. Okay, the one reason why products are difficult to separate if they are used to reduced from here. These are your two products, right? Because both of them are solids. Both products are solid, so it's harder to separate them. So next one, mass calculation. Here. Ratio mass. What is given to you? 1.2 kg of silicon dioxide, which is silicon dioxide here. That one, the silicon dioxide. And what will they want you to find? They want you to calculate the minimum mass of magnesium. Magnesium is here. So silicon dioxide is SiO2. There's no ratio number, so it's 1. Mg, the ratio number is 2 on there. That's what they want. Right, relative formula mass of what? SiO2. Si is 28 plus O2, so 2 times 16, that makes it 13. So what's that then? 60. Mg works out to be 24 anyways, you can see. So SiO2, how much is it? Now, am I allowed to put 1.2 kg? Well, it depends. Look, if you put 1.2 kg, you will get a kg, but they want it in grams, so I better off put it as what? 1200 grams. Okay. 1200 grams divided by relative formula mass of SiO2 is 60. That gives you 0 can cancel, that's just 20. 1 to go to 2, you just times it by 2, so same thing you do, times it by 2, that makes it 40. Times by relative formula mass of that is 24. 40 times 24, 960 grams is the answer of magnesium. Okay, good. Next one, a volume question again. Cool. This is probably the second volume question we're doing, isn't it? If you keep account of it. Ratio mass. So what is given to you? You got 14 grams of iron, so that is what given. And what will they want you to find? Calculate the volume of chlorine. 14 grams of iron means chlorine they want there. Iron is Fe, the ratio number is 2. Chlorine is CO2, is ratio number is 3. Relative formula mass of what only you need, remember, Fe you need, which is 27. Do I need the CO2? Remember, because it's a volume question, you don't need the second one. 14 grams, okay, it's in grams, that's good. 14 divided by Fe. Fe is not 27. Fe is, why did I say Fe is 27? Fe is 56, sorry, my bad. Fe is 56, there you go, 14 over 56, which is what? 1 over 4. 2 to go to 3, what do you do? Times it by 1.5, same thing, times it by 1.5, 3 over 8, times it by, remember, you don't multiply the relative formula mass of CO2 because we don't know the mass. You said 1 mole is 24 dm cubed, so you just times it by the 24 decimeter cube, 24, which gives you 9 dm cubed. And they want the answer in dm cube as well, so you're fine. Okay. Good. Next one. Percentage of atom economy. Atom economy, that's the second thing that you need to know, is mass of desired product and total reactant mass times it by 100. Okay. The percentage atom economy for the reaction 2, what do you want to work out? You want to, so if you look at it, what is the desired product here? And we are looking at reaction 2, remember, yeah? What is the desired product? Do you think they would like water or they would like copper chloride? Most likely it's a copper chloride, isn't it? So what is the mass of the copper chloride, desired product? What's they told you? Copper chloride is 134.5 divided by total sum of all the reactant. This is your reactant, this is your reactant. Remember, anything on the left hand side of the arrow is your reactant. So what is it? CuO, which is 79.5 plus 2 times, remember it's a 2 times HCO. What is HCO? 36.5. 2 times 36.5 times it by 100 will give you an answer. Over. It'll give you how many decimal places? Doesn't say. 88.2. 88.2% of atom economy. Okay. Atom economy formula sometimes is given, but sometimes is not given. So you go to memorize it. Okay. And also percentage yield formula. So just memorize those formulas. Atom economy for reaction 1 is 68.5. Give the reason. If you look at it, atom economy is how much. So atom economy goes down if you have more waste products. If these, okay, if this is your useful product, this is also the useful product on that one. So which are the waste products? On this one I got 1 waste product. On the reaction 2 I got 2 waste products. So in reaction 1 there's more product such as CO2 and H2O. But in reaction 2, only waste product is the what was it? H2O. Okay, on the reaction 1 there's an extra waste product which is CO2. Okay, so that's why. The question is about extraction of metals. Calculate the relative formula mass of R. Okay, they told you this. The total relative formula of that is that. Okay, let's see. So 3H2, that makes it 3 times 2 hydrogen means 2. R is you don't know. Plus 3 oxygen. 3 times oxygen is 16. That should give you 150 apparently. That's a 6. That's a 48. R plus 54 equals 150. Take it away. 96. So that's the R. Identify R. 96. Who has 96 in here? Look through the periodic table. Your mass. So who has 96 mass? 96 number is on the top, yeah? So whoever has the 96 on the top, so the periodic table here, is MO. Okay. And that's the one. Okay. Because MO, if you look at it, I'm just writing on the side. The top number is what? 96. And the other one is 42. And this is your mass number, remember, right? relative mass or relative formula mass. The percentage of atom economy. You should know the formula for the percentage of atom economy. What is it? Mass of desired product divided by total reactant mass times by 100. So what do you think the desired product is in here? So like, you know, these two are your products. So one of them is desired. It probably is the SN, which is your tin, right? Because yeah, extract tin anyways. Okay, so it's tin. How much is that? Tin is 119 over the, what is it, total reactant mass. These two are your reactant. Whatever on the left hand side of the arrow is your reactants, right? So SnO2, let me just work out the relative formula mass. SnO2 is Sn is 119 plus 2 times oxygen is 16 plus 2 times 16, which would be 151. So that's 151 plus one more thing in here, carbon 12. Then you just times it by 100, right? Which gives you an answer of 73.01. Okay, percentage of atom economy. Okay, extracting tin. Remember, tin is your useful, desired product. Next one, the percentage atom economy of silver iodide. Oh gosh, atom economy is a desired product, which is what? Silver, percentage of silver iodide. What is silver iodide? Silver iodide, that one. What is it? That is AgL 235 over the total mass of reactant, isn't it? Total reaction mass, isn't it? What is total reaction mass? What is total reactant? These two are your total reactant anyways, because whatever on the left side of the arrow is reactant, isn't it? AgNO3, what is that? 170 plus what's the other one? Na sodium, which is 150 times by 100. You want the answer to three significant figures. 235 over 170 plus 150 multiplied by 100, which gives you three significant figure is 73.4. Okay, one reason why a high atom economy is used, because there is less waste produced. It's more sustainable. Sustainable method. Okay, you could say raw materials are conserved. Okay. Next one, surface area of this nanoparticle. Because it's a cube, you should know the surface area formula is 6x squared. They want it in nanometer, so we don't need to convert the nanometer. If you want to convert nanometer, remember, nano means what? Times 10 to the minus 9, if you do want to convert. Micro, this is micrometer, mu m, like micrometer. This is called micrometer, which is times 10 to the minus 6. Remember, it's in 3 times table, yeah? And then the other one is millimeter, if you want to convert, times 10 to the minus 3. Because remember, it's all of them are 3 times table. Always remember, okay? But in this question, no, it's only 3 mark anyways. Look, it's nanometer, that's fine. They want to keep it on nanometer. So 6 times for how many nanometer? 82 squared. 6 bracket 82 squared, that's the formula. You want that as a, what? It's 40344, which is as a standard form 4.0344, I think, times 10 to the power 4. Okay, you want it as a standard form anyways. There you go. Okay, why does it cost less to use nanoparticles than fine particles? Because nanoparticles always have a high surface area to volume ratio. So less amount of sunscreen, is it sun cream? Yeah, sun cream is needed to cover the same area. Because nanoparticle, the key point is nanoparticles have a higher surface area to volume ratio, therefore less amount of sun cream is needed to cover the same area. That's why less equals less, because you got less amount of sun cream needed, isn't it? Next one. What question is it? Is it percentage yield? You should know the formula, right? Actual mass over theoretical times it by 100 as your for the percentage yield. They want, what do they want? They want the actual mass, so the number is smaller. So what do you do? 13.5. So if it's smaller, so what do you times it or divide? What is 92.3% is 0.923, yeah? You times it. Okay. Which will give you 12.46. You got 12.46 kilogram. What is atom economy? You should know atom economy is the mass of desired product over total mass of reactant times it by 100. Okay, desired products. What is desired here? Produce nickel. Nickel is here. How much is that? 59 over total mass of reactant. These are your reactant. The one on your left hand side of the arrow is reactant, right? NiO is what? 75 plus C is also there, which is 12 times by 100, and you get an answer to 3 significant figures. %67.8. Next one. The calculate the nitrate give the formula. So a Ca is 2 plus NO, capital O apparently. 3 is minus. Minus means 1 minus. These two numbers are across the charges numbers. Ca is 1, you don't need to put it. NO free, just put it on a bracket, NO free. And then 2 of them, because there's 2 of this, isn't it? That's it. And this is the answer, right? Next one. Percentage atom economy for X is obtaining is 77.3. The relative formula, mass of X. Okay. Mass of desired product. What is the desired product? Is X. X. Over total mass of reactant. So which are your reactants? These are your reactants. The one that is on the left side of the arrow. XO3. So X plus O free. What is O free? Is 3 times O is 16. Plus 3 times hydrogen. H2 is 2 anyways, because H is 1 and H2 is 2, right? Times it by 100 equals 77.3%. So if you divide it, which will give you 0.773 on there. And this is X over, what is it? This is 3 times 16 plus 3 times 2, which gives you 54. So X and X plus 54 is that. We can multiply it over here. So what do you get? X equals to, multiply that, 0.773x plus what is 0.773 times 54 is if you multiply that, it's 41.742. Take away the, bring in on the other one, X take away the 0.773x, so 1 take away 0.773, which gives you 0.227, 41.742, and you just divide 41.742, 0.227. which will give you what? 183.9, which roughly you could say is 184 then. Calculate the relative mass on that. Okay, so that would be whatever that 184 mass it carries. It's tungsten, isn't it? W. It's W, which is tungsten, because it's 184. And what is the bottom number on the tungsten? 74. I'm reading off the periodic table because you will be given the periodic table. Yeah. Good. Next one. What do they want? Calculate the mass of salt, actual salt mass produced. Don't worry about the formulas. Very good. 92.8%, 0.928. Actual mass means it's smaller, right? So 12.5 times it by 0.928, isn't it? Which gives you 11.6 grams. It's produced. Okay. The percentage of mass of Fe3O4, percentage of mass of iron, how much iron is in there. Okay, so first relative formula mass, RFM, of Fe3O4, how many? 3 iron, 3 times 56, plus 4 oxygen, 4 times 16. How much is that? $232. And they want iron. How much iron is there? Iron is 3 iron, 3 times Fe is 56, over the total relative formula mass was 232, then you times it by 100, isn't it? Okay, the iron was 3 iron is there, you could see, 3 times 56, over the total relative formula mass is 232, times it by 100, which gives you an answer of 72.4%. Zn 2 plus NO free, and then it's just minus means 1 minus the numbers across. So Zn is just 1, so you don't need to put 1. Then NO free, just put it on a bracket, and 2, yeah, like that. Okay. Now, the mass of oxygen in there. How many oxygens are there? There are 4 oxygen. Could you see? 4 times oxygen is 16 over. They already worked out the relative formula mass for you, so you do not have to bother. 110 times it by 100. Which gives you 58.18. To 2 significant figure, 58%. Okay? Did I do significant figures right? Yeah, cool. Seems fine. Next one. The concentration. Okay, you should know the formula for concentration. Concentration is mass over volume. Okay, but they told you what mass should be. Look, mass should be in grams. In this case, volume should be in dm cubed. Okay, so concentration, they want the concentration. What is the mass? There you go. In grams, perfectly fine. 0.30, whatever. But the volume should be dm cubed. But you got centimeter cube. So how to go from centimeter cube to dm cube? You should always divide it by 1000 to go to dm cube. 25 divided by 1000 is 0.025. That's the decimeter cube. Okay, 0.025. How do I know it has to be in decimeter cube? Look at the unit. Look, it should be in dm cube, not in centimeter cube. You cannot have it in centimeter cube unless if the unit is saying centimeter cube. Then okay. It's 12. What is the unit? Grams per decimeter cube. Next one, they want the mass of oxygen in there. So how many oxygens are here? 3 oxygen. 3 times oxygen is 16 divided by the relative formula mass, which is they gave it to you, so you don't have to work it out. Times it by 100. %60. Okay. They want concentration, right? Concentration is mass over volume. What is the mass is? And remember, it's grams per dm cube, okay? mass is 3.2 grams. That's perfectly fine. The volume can't be in centimeter cube. It has to be in decimeter cube. So how to do it? Centimeter to decimeter, you divide it by 1,000. Yeah. So how many decimeter cube is it? 50 divided by 1,000, 0.050. What is it? 64 grams per dm cubed. That's the answer. Good. Yeah, that covers.